In Chapter 5, we're going to talk about inequalities in triangles. So today we are just going to be talking about inequalities involving angles and sides of triangles. So I know we have exterior angle theorem where if I'm looking at this picture, angle 1 would be equal to angle 2 plus angle 3. So since you need both angle 2 and 3 to add up to 1, then I can set up two inequalities. I know angle 1 is going to be greater than angle 2. I also know that's going to be greater than angle 3. So it's going to be, this outside angle is always going to be greater than the two on the inside that do not touch it. So in this figure, why is measure of angle 2 and measure of angle, or greater than measure of angle 3? Well, first I'm just have to kind of look at this picture. I've noticed I have two tick marks right here. Two tick marks mean they have equal sides. If they have equal sides, then I look at my opposite angles. This is going to be congruent to this. So I'm going to put same symbol on both picture. Now I'm trying to get to angle 2 and 3. Now if I look at angle 3, that's inside this triangle here. If I just concentrate on this triangle right here, I see that an exterior angle is angle 1. So I know since this is my exterior angle, angle 1, and it's not touching angle 3, I could write up that measure of angle 1 will be greater than measure of angle 3 because of the property we just talked about. And since measure of angle 2 and measure of angle 1 are congruent, then I know measure of angle 2 is greater than measure of angle 3 because of my isosceles triangle. So now I have to explain why is measure of angle 1 greater than measure of angle 4. Well, first I can write my equality. Measure of angle 1 is on the outside, so it's an exterior angle. So the two inequalities I can write up is measure of angle 1 is greater than measure of angle 3. It is also measure of angle 1 is greater than measure of angle 2. Because those are the two angles that add up to get my exterior angle. And now that I notice, I see an X here. Whenever you see an X, that means you have vertical angles. And vertical angles are always congruent. So angle 4 is going to be congruent to angle 3. Now I can replace angle 3 with angle 4. So measure of angle 1 is going to be greater than measure of angle 4. Here's our next theorem with angles and triangles. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So if I know in this picture that AZ, this side length right here, is larger than XY, I also know that angle Y is going to be larger than angle Z. Because if XZ is my longest angle, or longest side, then my largest angle is going to be opposite my side. So then I know that Y is going to be greater than Z because Z is opposite XY. So I'm asking the question, which corner of the triangular plot of land forms the largest angle? So if I look at this, I'm going to be labeling my sides from largest to smallest. So if I look at here, this is my largest, this is my second largest, and this is going to be my smallest. So when I'm looking at my angles then, opposite my largest side is going to be my largest angle. So angle B is going to be my largest. Opposite my middle side is going to be my middle angle. Angle A is going to be the middle. And opposite my smallest side is going to be my smallest angle. That's going to be angle C. I'm asking what plot of land forms the largest angle, and that would be angle B, because it is opposite my longest side. So just how we can go from sides to angles, we can also go from angles to sides. If I know that this angle A is going to be larger than angle B, then I know the side opposite of it, BC, is going to be larger than AC. So I can write up this inequality. Here I have to number my sides from shortest to longest. So first I'm just going to look at my angles and say which is my smallest angle. 51 is my smallest. My second smallest would be 64. And my largest would be 65. So now I'm going to put my side lengths from shortest to longest. So opposite my 51, so if I'm looking across my triangle, it would be LM. That's going to be my smallest side, and you have to make sure to put your symbol above your two letters. Then I look at my second largest angle at 64, and opposite 64, the side I would be looking at if I were at 64 would be MN. And again, you have to make sure to put the line above your two dots, your 2 points, otherwise it would be marked incorrect. My largest angle is 65, so opposite the sides of 65 is going to be LN. So this would be my side lengths from shortest to longest. And the last theorem we have today is triangle inequality. In order to have a triangle, if I know 3 side lengths, in order for it to be a triangle, 2 of the triangles, when added together, have to be greater than the third side length. So when I'm looking at these 3 inequalities, I have 2 sides is greater than my third side. And then I have 2 different sides is greater than my third side. And then my 2 last sides are greater than my third side. If that is not true, then it cannot form a triangle. There is no way that you could set up a triangle. So let's say if I have lengths 3, 4, and 7. Is that a triangle? Well, if I look at this, is 3 plus 4 greater than 7? Well, 3 plus 4 is 7. Is 7 greater than 7? No. It's equal to. So then this would be not a triangle. So I'm going to test out, can these 3 lengths be a triangle? So I'm going to first see if 3 plus 7 is greater than 8. I'm also going to write out the equation. Is 3 plus 8 greater than 7? And then finally, I should have 7 plus 8 greater than 3. So if I simplify all of these, I have 10 greater than 8. That checks out. 3 plus 8 is going to get 12 is greater than 7. That checks out. And finally, 7 plus 8 is going to give me 15, which is greater than 3. So yes. Right now I want you to pause and test to see if these 3 lengths can form a triangle. Right when I wrote out my first equation, I got 5 plus 10 is greater than 15. I know 5 plus 10 is 15, so then no, this cannot form a triangle because it has to be greater than 15. So in this problem, I'm given 2 of my 3 sides. So I have to figure out what the range is. So range is all possible answers that the third side could be. So how am I going to figure this out? I'm going to label my third side X. X is going to be my third side. And then I'm going to write up my 3 equations. I know 4 plus X has to be greater than 7. I also know that 7 plus X has to be greater than 4. And 7 plus 4 has to be greater than X. Now, one of these inequalities will be impossible because it will give me a negative. So let's see what happens. First, when I'm going to solve, I have to subtract 4 from both sides. So X is going to be greater than 3. Second, I have to subtract 7 from both sides. So X would be greater than negative 3. And for the last one, I just have to combine my 7 and 4, which 11 is greater than X. Now when I look at this, X cannot be a negative side because a side length is a positive number. So this right here is not possible. So now I'm going to write these 2 inequalities as a compound inequality. So X has to be in the middle. So my lower bound is going to be 3. My upper bound is going to be 11. So X can be greater than 3, but it has to be less than 11. Not or equal to. Remember, it can't be or equal to. So this would be my final answer. X can be any number greater than 3 and less than 11.